Hey y'all, welcome. Today we're just going to kind of ease into the course and review a bunch of old Algebra 1 and 2 concepts to kind of get us back into the swing of things. So yeah, this first day we're just going over how to solve linear equations. We'll go through this step by step. And first we'll start with these properties of equality. So we've got 4 properties of equality, and one is for addition, one for subtraction, multiplication, division, but they all more or less operate the same way. And that is whenever you're trying to isolate a variable, so we're trying to solve these equations for the unknown, what we are allowed to do is perform the same operation to both sides. So in other words, like if this left-hand side says x minus 3, what we can do to sort of undo this minus 3 is we can add 3 to both sides of the equation. Let's make that a little smaller here. Now, the way I'm going to show this is just writing plus 3 on both sides. And then I'm going to draw a little horizontal line here to sort of like section off my work. There we go. Okay, so what I want to show you here is that if I subtract 3 from x and then add it back, this minus 3 plus 3 is just going to equal 0. So these two operations cancel each other out. And that's kind of the whole point of using these properties of equality, is to get everything that's on the same side of the x to go away, essentially. We're trying to isolate that x. So here, when I add 3 to both sides, I'm going to end up with just x on the right-hand side, and then negative 5 plus 3 is negative 2. So my solution to this is negative 2. Let's just talk a minute here about what a solution is. So when you're solving an equation, what you're trying to find is whatever the value that makes the equation true. So in this case, if x was negative 2, we would have a true statement. Negative 2 minus 3 equals negative 5, and that's true, obviously. It is possible for equations to have more than one solution, or sometimes there are no solutions. And we'll come up with a few linear equations that fall into one of those two categories. But in general, the vast majority of linear equations will only have one solution. So let's look at number 2. Number 2, we've got, notice here the y is on the right side. I kind of like having the variable on the left side. So I might rewrite this, but I can also wait till the very end to do that too. Either way, I'm trying to isolate the variable. I'm trying to get the variable by itself on one side of the equation. So right now it's on the right-hand side, and we've got this plus 2.8. So what we want to do is we want to subtract 2.8 from both sides to get our solution. Now during this course, you will be allowed to use a scientific calculator for the most part. I don't want basic arithmetic slowing you down or anything. So I'm going to go ahead and anytime I'm dealing with negatives, in particular decimals and fractions, for the most part, I'm going to be using a calculator to do that arithmetic, just because I want to emphasize that you're allowed to do that too. So let me go ahead and pull up a calculator here. Instead of trying to do 0.9 minus 2.8 by hand, it doesn't want to get pulled up here. Let me see here. I think I need to do this. There we go. Okay. Now the calculator I'm showing on screen here is a TI-84, which is a graphing calculator. I want to kind of advise you against getting the graphing calculator. You really won't need it this year. Scientific calculator will do just fine. I just don't have a program to use that. So I'm going to go with this. I won't be using any of the functions that you can't use on a typical scientific calculator, so don't worry about that. Okay, so here, most of the time I'll only be using it for arithmetic anyway, or just you don't even really need a scientific calculator. You could use a 4-function one for the majority of what I'm going to be showing you. All right, so anyway, yeah, 0.9 minus 2.8 is going to be negative 1.9. So I have negative 1.9 equals y. And you're fine to leave your answer like that. I really like having the variable on the left-hand side. I think it reads better. You're saying y equals this rather than negative 1.9 is y. I don't know. They're logically equivalent, but I kind of like having it on the left side. So you'll see me always rewrite this with the variable on the left-hand side. Number 3, we've got n plus 3 equals negative 7. So to undo this plus 3, we want to subtract 3 from both sides. So here we have negative 7 minus 3, which is going to be negative 10. For number 4, we've got g minus 1/3 equals negative 2/3. So I'm going to add 1/3 to both sides. Here, don't be afraid to use a calculator. I'm going to be, I think, comfortable enough adding 1/3 to negative 2/3. But yeah, your scientific calculator should have a fraction button, so don't be scared of these fractions. Just work with them like you would any other number. If you don't want to, if you don't feel confident about doing the arithmetic in your head, then feel free to use that calculator. Let's get you through there. So here we've got g equals negative 1/3. For number 5, we're going to subtract 3.9. Here I am going to use a calculator, I think. Anytime it's not like, especially when I'm dealing with negatives and I get a little uncomfortable. On number 4, I already had a common denominator, so I wasn't going to feel that uncomfortable. But here, I just want to make sure I get the right solution here. So I'm going to go ahead and pull my calculator back up and go ahead and do that arithmetic. Oops. Okay, let's see. So we got negative 10.4. That's going to equal p. That's another problem that ends up with the variable on the right-hand side, which again, technically is fine, but I just really like having it on the left-hand side, and I'm going to try to stay consistent with that throughout the year. Number 6. Here we want to multiply both sides by negative 5. Here we've got a n divided by a negative 5, so we want to undo that. And we want to do that by multiplying both sides by negative 5. So I'm going to show that on both sides. I'm trying to space this out for you. Okay. So yeah, negative 3 times negative 5 is going to be positive 15. And that's our answer for number 6. Number 7, we've got pi x equals negative 2 pi. So here we're going to divide both sides by pi. Now, you really don't need a calculator for this one. I know pi is irrational, and that might make you think like, oh, I need a calculator to get this one. Because, what's negative 2 times 3.14 divided by 3.14? But since this other side already has a pi, we're just going to leave our answer here in terms of pi anyway. We will end up with no pi, so it'll be kind of moot. But if we were to have ended up with a pi in our answer, we wouldn't put it in the calculator anyway. Like if our answer was 3 pi, we just leave it as 3 pi. So pi divided by pi is 1. You can kind of see this is going to cancel out on both sides. And so we're just left with x equals negative 2. That's it for this one. This pi symbol is about 3.14. And this is going to be very important to what we're going to study later in the year. So yes, it's a good idea to start getting comfortable with that number now. Number 8. We need to divide both sides by 1.3. So I'm going to show this little fraction bar showing the division. So we're going to divide both sides by 1.3. Let's see, does 13 go into 15? I think it goes in 4 times, but I'm going to, we've got these decimals here. I'm going to use a calculator again on this one. Let's see, I'm guessing the answer is 4, but I might be off. And yeah, so it is actually exactly 4. So z equals 4. For number 9, we've got 2/5 x equals 1/7. So here, you've got a couple options. You can actually take this in 2 steps if you want and multiply both sides by 5 and then divide by 2. But I like kind of just throwing it all in together and then using the calculator to do the arithmetic for me. So I'm going to divide both sides by 2/5. Now, if you're going to try to do this by hand, which again I wouldn't really recommend here, but you would change the division into a multiplication problem and then multiply 1/7 by the reciprocal of 2/5. So you do 1/7 times 5/2. But yeah, I'm just going to do this in the calculator. There's no reason to do this by hand. So I'm going to go ahead and throw in a fraction here. If I can. There we go. 1/7. And we want to divide that by 2/5. Should get 5/14. Yep, and there we go. So x equals 5/14. 5/14. All right, so that's going to take care of the first page. This next page is going to be more one-step equations, but here we're going to have to set up the equations. Number 10 says, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. And a little hint over here, in case you forgot your distance formula, distance equals rate times time. So what we'll need to do is just plug in the appropriate values here and solve for the average speed, which is going to be the rate. So the distance was 200 meters. And that's going to equal the rate times the time, which is 19.32 seconds. We will make sure to write our units at the end here. If you want to keep track of them. Again, this is going to be meters and this is going to be seconds. So then we just want to divide. We want to divide both sides, and just to clean this up, I'm going to actually delete this. It kind of looks like we have some variables in there. I'm going to divide 200 meters by 19.32 seconds. So we're going to divide both sides here. By 19.32. And so we've got 200 divided by 19.32. And okay, so that gives me 10.3. It says the nearest hundredth of a meter per second. That's going to be 2 decimal places. So we'll say the rate is approximately, because we are going to round, so I'm going to use this little squiggle equals 10.35, and that's going to be in meters per second. So let's go ahead and say meters per second. Okay, so that would be his average speed to the nearest hundredth meter per second. That's pretty fast. It's a lot faster than I can run, obviously, yeah. Okay, number 11. On January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to -4 degrees Fahrenheit. What a drop there. That's a 60-degree drop. Jeez. At 9:27. Write and solve an equation to find how many degrees the temperature fell. Okay, well, spoiler alert, I already gave you the answer, but let me show you how you would write the equation here. We would say 54 minus x equals -4. That's basically the setup here. So what I can do here is I'm going to start by subtracting 54 from both sides. This is actually going to be a 2-step equation. I suppose you could set it up for it to be a 1-step equation, but I think setting it up this way is going to be, more intuitive. 54 minus some number equals -4. So we're going to subtract 54 from both sides, and that's going to give me -x, which is the same as -1x equals -60, or no, 58. Okay, so yeah, I said 60. My spoiler was off. Yeah, see, that's what happens when you try to do too much work in your head. Here I'm going to divide both sides by -1, and so I'm going to get x equals positive 58. So anytime you have a negative sign on your variable, and that's sort of, the last thing left over, what you can do is just either multiply or divide both sides by -1 and get rid of that negative sign by essentially just flipping the signs of every term. So, if you have negative x or negative whatever the variable is equals, whatever, you can multiply or divide both sides by negative, and that'll give you your answer. All right, I do want to go ahead and throw on some, let's see, so we want to say some units here. We got 0 degrees. Maybe I'll write it like this. So 58 degrees Fahrenheit. And this describes how many degrees the temperature fell. Okay, you don't really need these little squigglies under there. Not sure why it doesn't like those. I guess because those aren't real words. I don't know. All right, number 12. You thought the balance in your checking account was $68. When your bank statement arrives, you realize that you forgot to record a check. Oh, no. The bank statement lists your balance as $26. Write and solve an equation to find the amount of the check that you forgot to record. Oh, no. Oh, my. So 68 minus some unknown amount is going to equal 26. So just like in the last problem, we are going to subtract 68, that constant, from both sides. So I'm going to write minus 68 on both sides. And so that'll leave me with negative x equals, and then we've got, I'm going to go to the calculator here. We've got 26 minus 68, negative 42. Okay, and just like with the last problem, if you want to get rid of that negative sign, you can just multiply both sides by -1, which will make that 42 positive. So that, let's see what the units here are in dollars. So, oh, what's going on there? Let me add a dollar sign in there. And here's what we'll do. Oh, there we go. Strange. Okay, so yeah, $42 is what we got here. 13. The sum of the angle measures of a quadrilateral is 360 degrees. So when it says the sum, it means if you add them all up, you get 360. Write and solve an equation to find the value for x. So here we've got 60 plus 115 plus 85 plus that x equals 360. Now, there's two ways you could go about doing this. One is to add these all up front. You can combine like terms, which is something we'll do more of later. Or you could subtract these each individually. I think it's probably easier to go ahead and add them up and then do the subtraction. So that's the way I'm going to do this. So 60 plus 115, let's see, 60 plus 115 plus 85 is going to be 260. So it's 260 plus x equals 360. And you may be able to do that subtraction in your head because the numbers line up pretty nicely, but I'm still going to show it. So we're going to subtract 260 from both sides. Remember, anytime you want to add, subtract, multiply, divide both sides by anytime you want to add, subtract, multiply, or divide a number, you do have to do it to both sides. So you can't just do it on one side, or else the equation will no longer be balanced. So this is going to end up being x equals 100 degrees. Go ahead and steal this little degree symbol up here. If it'll let me. There we go. Okay, 100 degrees. Number 14 says write and solve an equation to find the area of base B. Include units and leave your answers in terms of pi. So that's what I was referring to earlier, is if we end up with a pi in our answer, we don't want to round it or anything, we're just going to leave it in terms of pi. So here we've got the volume equals the base area times the height, and the volume here is going to be 84 pi inches cubed. So 84 pi inches cubed equals the base area, which is what we're trying to find, times the height, 7 inches. So I'm going to actually put the 7 in the front. Okay, so if we're looking for the base area, we are going to divide both sides by 7. 84, is that divisible by 7? Let's see, 7 goes into 8 once, 1, 14. Yeah, I think actually it does. I think it'll be 12, but I'm gonna throw it in the calculator just to make sure. Notice I'm not gonna put the pi in the calculator because I'm gonna be left with that pi anyway. So just to figure out how that reduces, it does become 12. So 84 divided by 7 is gonna be 12. I do still have that pi in there, so I'm gonna include that. Get 12 pi equals b. All right, so there's a few little word problems there where you have to set up and solve a one-step equation. A couple of these, we set them up in a way that maybe took 2 steps. I don't think there were any 3 steps. But now we're going to start getting into multi-step equations where we do have these multiple steps. So to solve these multi-step equations, the first thing you're going to do, if it applies to your equation, is use the distributive property, which is, if we look a little down here, a little further down, is when you have a number multiplied by an expression in parentheses. So that's what I mean by the distributive property. I'll define that in just a second. Combining like terms. What that means is you're going to add or combine all of the terms that have an x, and then you'll also combine all the terms that don't, all the constants. So we'll do that to kind of simplify the equation first, and then we'll use the properties of equality to isolate the variable. And since you may have to use multiple properties of equality, you're going to do these in sort of reverse PEMDAS order, where first you'll take care of the multiplication and division. I'm sorry. Oh, that's wrong. It should be addition and subtraction first, and then multiplication and division. Oh, boy. I'm going to have to fix that. So first, multiplication division is wrong. No. We're going to first do addition and subtraction. So I'm going to fix this here right now while we're talking about it. And then the document I print out for you will likely be fixed at that point. Oops. These are backwards. Okay, I'm glad I caught that. Okay, so let's just work through a couple of 2, 3-step equations, and we'll get into some distributive property. I'll define that, and then at that point we're just going to be solving equations. So yeah, this 2-step equation says 2.5x minus 13 equals 2. So we'll start by adding 13 to both sides. So you always want to take care of that addition and subtraction before the multiplication and division. So I'm going to add 13 to both sides. And then that's going to give me 2.5x equals 15. And then I want to divide both sides by 2.5. So again, take care of the addition subtraction first, followed by the multiplication or division. Okay, so here we have x equals whatever 15 divided by 2.5 is. Yeah, I'm going to get the calculator for this one. There we go. So let's see here. We got 15 divided by 2.5. So it's going to be 6. So here we get our solution, which is x equals 6. So 6 is going to make this equation true. 2.5 times 6 minus 13 is 2. Now if you've got multiple terms that have an x on it, you do need to combine those like terms. So you just add or subtract them. Here we've got 9x minus 6x. So if you have 9 x's and you take away 6 of them, you're left with 3x. So the variable is going to remain whatever it is. You're not really going to mess with that. you're just going to combine the coefficients. So this would be 3x plus 15. Then we're going to subtract 15 from both sides using that property of equality. And all just kind of comes back to these properties of equality when you're solving linear equations. All right, negative 12 minus 15 is going to be negative 27, and that's going to equal 3x. So we're going to divide both sides by 3. All right, so dividing both sides by 3 is going to leave me with, let's see, negative 27 divided by 3 is going to be negative 9, and that's going to equal x. Now, just like with all the other problems so far, I'm going to rewrite this so that I have x on the left-hand side. This is really just an aesthetic preference on my part again, but I'm going to go ahead and do that. So x equals negative 9. I just think it looks and reads better. Okay, so now we're going to throw in the distributive property. Let's talk about the distributive property briefly here. The distributive property is a property that explains how to combine multiplication and addition. So if you have a, like just some number a, times, let's say b plus c, the distributive property says that we are going to distribute this multiplication. Essentially what we need to do is multiply what's on the outside of the parentheses by everything that's on the inside of the parentheses. So I'll usually show this little, these little arrows to showcase that I'm actually doing the distributive property here. And so you'll have a times b plus a times c. So this is what the distributive property actually is. Okay, so how that applies over here is we're going to multiply the 2 by both 1 and negative x. So 2 times 1 and 2 times negative x. That'll be 2 minus 2x. And then we have plus 3 equals negative 8. We do have some like terms we need to combine here. We've got the 2 and we've got the plus 3. These are like terms because neither one has an x. So when you're combining like terms, I'm not sure if I really specified this, but like terms are going to be terms that have the same variable with the same exponent, or in the case of constants, the ones that have no variable. So we can combine these. 2 plus 3 is going to be 5. So I'm going to rewrite this as negative 2x plus 5 equals negative 8. Then I'm going to subtract 5 from both sides. Okay, so that's going to give me negative 2x equals negative 13. And then I want to divide both sides by negative 2. That's going to isolate x for me. Notice how I'm showing every step. I'm not skipping anything, and I really encourage you to show all your steps. I know it takes a little bit more time to show all the properties of equality that you're using and whatnot, but you'll be way less likely to make an error if you're not trying to do everything all in your head. So let's see, negative 13 divided by negative 2, that's going to be some kind of decimal here. So yeah, I'm going to type that in. I just realized you probably can't see what I'm doing here, so I'm going to scroll up. There we go. So negative 13 divided by negative 2 is going to be 6.5. All right, so we have a few more examples that are going to be very similar to this. And so let's see how many we got. We got 3, and then we've got some. Okay, then we got some more word problems. So yeah, I'll try to work these a little bit quicker since we've kind of gone over all the steps already. This is just going to be practice. In fact, what I encourage you to do is try to do these on your own, and then pause the video, come back, and see if you got them right. Okay, so we'll start here. I think I'll do the same thing. I think what I'm going to do here is for each of these problems, I'm going to work them out, okay, and then just come back with all the work shown. Okay, so I'm not going to narrate this step by step as I'm working it out, but I will go through the steps after I work it out. So take a moment here, press pause on the video, and try to do these yourself. Hopefully that was enough time for y'all. So number 15, we're going to start with the distributive property. So we get 3x plus 3 instead of 3 times x plus 1. And then I boxed right here the like terms. 3 plus 6 would be 9. And then I subtracted 9 on both sides. And that's going to give me 3x equals negative 18. And then finally divide both sides by 3 to get negative 6. So there's number 15 completely worked out. Number 16. First thing I did, just like, well, the first step on all of these is going to be to use the distributive property. So here I'm going to multiply negative 2 by y minus 4, and that gives me negative 2y plus 8 right here. Okay, then I boxed the like terms that I was going to combine just to kind of point them out. Negative 2y plus 3y is going to be 1y. And then if I subtract 8 from both sides, I'm going to get 5 equals y, and I just reverse that around and put the variable first, and get y equals 5. Number 17 has negative 4 being distributed to m plus 5. So we're multiplying negative 4 times m plus 5. That's going to give me negative 4m minus 20. Then I'm going to combine my like terms, which are going to be these linear terms with m. So negative 4m minus 3m is going to give me negative 7m. And then I have the minus 20 equals 35. At that point, I'm going to add 20 to both sides to get negative 7m equals 55. And then dividing both sides by negative 7 gives me this fraction. And I think this is the first time that happened here where we didn't get like a nice clean number. So, but yeah, so we get negative 55 over 7. So here we've got some problems where we have to set up the equation and then solve it. So 18 says solve for b, and it also tells us that the sum of the angle measures is 540 degrees. So what we need to do is we need to add up all these angle measures, set it equal to 540, and then solve the equation that we get. So I'm going to see if I have enough room to put it here, because there's going to be, well, let's just see. So we've got b plus 45 plus 3 halves b. Not really going in any particular order here. 2b minus 90, and then we have a plus 90, and all that should equal 540. Yeah, it did not quite fit. So I'm going to move it down here. So yeah, basically I'm just adding all the different angle measures together, setting it equal to 540, because that's what it says the sum of the angle measures is. So next step, I'm going to add together all my like terms. So I'm going to box all my like terms here. I've got b plus b. I've also got this 3 halves b and a 2b. So I'm going to combine all those. And then I'm also going to combine my constants here. So I've got 45 minus 90 plus 90. Okay, so I'm going to combine everything that's in the boxes, and then I'm going to combine everything that's being underlined here. So 1 plus 1 plus, I'll come back to this, plus 2, so it'll be 1 and 1 is 2, plus 2 is 4, plus 1.5 would be 5.5. So we just say 5.5b. Or if you want to write it as a fraction, it'd be 11 over 2b. And then plus 45, because we've got 90 minus 90, this is just 0 right here. and then plus 45 would be 45. So now we've got a nice little two-step equation. And we could solve that by using our properties of equality. Just make sure we do them in the right order. We want to take care of the addition first. I'm going to subtract 45 from both sides. That'll give me 5.5b equals 540 minus 45 is going to be 495? Yeah, 495. And then we're going to kind of run out of room here. So I don't like not showing every single step, but because I'm running out of room, I'm just going to say what the step is and write our final answer here. So we're going to divide both sides by 5.5. And I want to make sure my arithmetic is on point here, so I'm going to use a calculator and do, what was it? 495 divided by 5.5. All right, so we get 90. That's a nice number. Okay, so B is 90. So yeah, I couldn't quite fit it in there. Just kind of ran out of space. But maybe I'll make a little note here since I didn't really have room to write it. Divide both sides by 5.5. Okay, so that's number 18. Number 19 says the perimeter of the tennis court is 228 feet. What are the dimensions of the court? So we're going to solve this very similarly here. We're going to add up all the side lengths. So we've got W plus 2W plus 6. And then we've got the other two sides, which aren't labeled. But since this is a rectangle, we know that the opposite sides are congruent. So if this is 2W plus 6, then this top side's got to be 2W plus 6. And if the side is W, then this side over here has got to be W. So we have another W and we have another 2W plus 6. And the perimeter is 228 feet. So first things first, just like with this last problem, I'm going to combine my like terms. I've got some W's. Looks like a total of 1, 2, 3, 4, 5, 6 W's. And then I have 6 plus 6 is going to be 12 for the constants. So yeah, I've got 6W plus 12 equals 228. And then I want to solve this just like I would a two-step equation. I'm going to subtract 12 from both sides, take care of that addition first, using the subtraction property of equality. And I think we're going to run out of room like the last one. Should have left a little bit more space here, I think, on this. Okay, so 6W equals 228 minus 12 is going to be 216. Yeah, I think that's right. And then here I'm going to divide both sides by 6. Probably get away without using a calculator on this one, but just to be on the safe side, I'm going to go ahead and type in 216 divided by 6, which is going to be 36. And there's number 19. Just like with the last one, I kind of ran out of room for that last division step. So I'm just going to make a note here, like I did before. That's not going to fit either. Let's see here. Let's just move all this stuff over here, just move it over a little bit. And here we want to divide both sides by 6. And real quick, before we move on from number 19, I do want to make sure that we're answering the questions being asked here, which is, what are the dimensions of the court? So if we know that W is 36, one of the dimensions is 36 because it's just W. So we'll say, we'll answer this as a complete sentence. The dimensions of the court are 36 feet by, and then we got to figure out what this length is. So it's 2 times 36, which would be 72, plus 6 would be 78. So 78 feet. So that's a more complete answer here, rather than just giving the value of W. Because we do want to make sure with these word problems that we're answering the question that's being asked. Okay, yeah, let's move along. We've got some more word problems here. The sum of twice a number and 13 is 75. So the sum of twice a number, that's going to be 2x, and 13, so the sum means we're going to add them together, is 75. Write an equation and solve it to find the number. So there's the equation. Now we're going to solve it. So we're going to subtract 13 from both sides. That leaves us with 2x equals, what would that be, 62? And then we're going to divide both sides by 2. And so we get x equals 31. Okay, yeah, there we go. That's the number. Write an equation and solve it to find the number. So the number is 31. 8 plus the quotient of a number and 3 is negative 2. Write an equation and solve it to find the number. So 8 plus the quotient of a number and 3, so x over 3, is negative 2. So quotient means you're dividing. Is the equal sign. Plus is obviously plus. So let's go ahead and solve this. And we'll do that by subtracting 8 from both sides. And then we have x over 3 equals negative 10. Then we're going to multiply both sides by 3. That's going to cancel out with that divide by 3. And that'll leave us with x equals negative 30. And that's the number. Okay, number 22 says you want to hang 3 equally sized posters on a wall so that the posters on the ends are 3 feet from the end of the wall. And we can see that in the diagram. You want the spacing between the posters to be equal. Write and solve an equation to determine how much space you should leave between the posters. So what I'm going to do is call this distance between the posters x. That's what I'm trying to find here. That distance and this distance right here, both of these in red, these little red segments. So that one's x, and that's x as well. So we're just trying to figure out what x is. So the setup here is we're just going to add up all these segments, set it equal to 15, and then solve for x. So we've got 3 plus 2 plus x plus 2 plus x plus 2 plus 3. Just kind of going in order there, equals 15. Now we want to combine our like terms. So that's going to be 3 plus 2. Going to combine that. We're going to combine another plus 2 and another 2 plus 3. And then we also want to combine the x's. So we've got one positive x, another positive x. So we'll combine those as well. X plus x is going to be 2x. And then 3 plus 2 is 5, 6, 7, 8, 9, 10, 11, 12. So 2x plus 12 equals 15. We're going to subtract 12 on both sides. So that'll give me 2x equals 3. So x is going to be 1.5, I think. Let's see here. So divide both sides by 2. And then our final answer here will be 3 divided by 2, which is, you can leave it as 3 halves, or, if you like decimals better, you could say 1.5. We are talking about feet here, so maybe 1.5 is kind of a better way to answer it, just because that's how if you're talking to someone, you'll say, oh yeah, 1.5 feet, instead of like 3 halves feet. It sounds a little bit more natural, I think. So yeah, how much space you should leave between the posters? Yeah, 1.5 feet. Okay, our last section here has to do with solving equations with variables on both sides. To solve equations like these, basically what you want to do is move the terms that have x's all to the left side and move all the constants to the right-hand side. And while it doesn't really matter which one goes on the left and which one goes on the right, you want to make sure that those different kinds of terms are separated out. So first, you want to do any simplification that you can, distributive property, combining like terms, that sort of thing. And then when you go to move things around, you're going to use those properties of equality to move the like terms all to one side. So let me show you, like with number 23, what we can do is add 4x to both sides, and that way I collect all these linear terms that have x on the same side of the equation. So after I add 4x to both sides here, I'm going to be left with 10 equals whatever negative 9x plus 4x is, and that'll be negative 5x. From there, you can just solve it like we did all the previous problems. Here we want to divide both sides by negative 5. And then that's pretty much it. The only other thing I'm going to do here is rearrange the equation. I do get negative 2 equals x, and I'm just going to rearrange this to put the x on the left-hand side, and so I get x equals negative 2. Number 24 is going to be kind of similar, just has a little bit more going on with it. So I do need to apply the distributive property first here, so I'm going to multiply 3 by both of these terms, and I'm going to multiply 1/4 by both of these terms. Now, multiplying by a fourth is pretty much the same thing as dividing by 4, so whichever way is easier for you to mentally compute that, you want to think about it that way. So 3 times 3x is going to be 9x, 3 times 4 is going to be 12, so we get 9x minus 12. And then we've got 1/4 times each one of these, so 32 divided by 4 is going to be 8. So we get 8x. Is that right? I'm going to brain fart here. 16, yeah, 8x. And then 56 divided by 4 is going to be 14. Let me think. 4 times 4 is 16. Yeah, that checks out. Okay, so now I've got all the simplifying done. Now I just need to move terms around to get the variables on the same side. So I'm going to kind of do both of these steps at the same time here. Because basically what I want to do is I want to collect my constants here on the right side and my linear terms on the left side. So to do that, I'm going to subtract 8x from both sides to collect the x's on the left, because right here I'm going to cancel out these two x's. And then at the same time, I'm going to add 12 to both sides so that I can collect my constants on the right-hand side. So I'm going to do basically two steps in one here. 9x minus 8x is just going to be 1x. Negative 12 plus 12 is 0, and that's kind of what I want to happen. I want that to zero out. And so on the right-hand side, I have 8x minus 8x, that's 0 again. The whole point of doing that was to get the x's on the left-hand side. And then 14 plus 12 is going to be 26. So my solution to this equation is going to be x equals 26. We've got just two more examples here, and the overall process is going to be the same here. So if you want to work these out on your own first and then look at the solutions, it's not a bad idea. But I'll just go ahead and work these out for you. So first I'm going to distribute the 1/2, and that's going to give me 3h minus 2 equals negative 5h plus 1. And then I'm going to collect my terms. I'm going to collect all my variables on the left-hand side. I'm going to collect my constants on the right-hand side. So to collect the h's on the left-hand side, I need to add 5h to both sides. And then if I want to move my constants to the right side, I need to move this negative 2 over here. I need to add 2 to both sides. So 3h plus 5h is going to be 8h. And then the 2 minus 2 cancels out. So does the 5h minus 5h. And I have 1 plus 2 is 3. So I have 8h equals 3. I'm going to divide both sides by 8 here. I'll be left with h equals 3/8. And that's my solution for number 25. For number 26, we've got a nice little distributive property on both sides here. So I need to multiply negative 3/4 to both of these numbers. And I might break out the calculator there just because I'm multiplying by negative 3/4, and I don't want to leave this arithmetic up to chance that I'm going to mess up something mentally. So yeah, let's pull up the old calculator here. All right, looks like everything got cleared out. Very good, okay. So we've got negative 3/4. Oops. Let's try that again. Negative 3/4 times 8, so that's going to give me negative 6, and then negative 3/4 times 12. And we get negative 9, okay? So we're going to get negative 6n minus 9. On the right-hand side, this will be a little bit easier to do mentally, so we don't really need the calculator for this one. Go ahead and close that out so it doesn't take up too much space. 3 times n is just 3n, and then 3 times negative 3 is going to be negative 9. From here, we're going to combine our like terms by using those properties of equality like we have on all the previous problems. So I'm going to subtract 3n from both sides, and I'm also going to add 9 to both sides. So these problems where you have variables on both sides, you do want to be a little careful about trying to do 2 steps in one here, but it is way more efficient to do it this way. So we get negative 6n minus 3n is negative 9n. And on the right-hand side, we just get, now wait a minute, do we just get 0? Let me just double check my math here. I think we do get 0. Yeah, okay, no big deal. So yeah, then we're going to go ahead and divide both sides by negative 9, which you probably already know what that's going to equal because we're dividing 0 by anything. It's going to give you the same thing. And I'm going to show my work anyway. I'm not going to take any shortcuts here. And yeah, so we get 0. It's going to be our solution. So we get n equals 0. Okay, so the last thing that we need to talk about are these identities and contradictions. So an identity is any equation that's always true. So maybe I'll make a little note out here. An identity is an equation that is always true. Okay, so the way that in other words, like it doesn't matter what you plug into the variable, you'll always get a true statement. The way that you want to express your answer here, if you're solving an equation and you end up with an identity, is you'll say x is all real numbers, or it can be all real numbers. Okay, and basically it's saying that x could be anything, or if you, like in 28 we have y, you'd say y could be all real numbers. A contradiction, on the other hand, is an equation that is never true, okay? So in other words, no matter what you plug into the variable, you always get a false statement. Okay, so you would say something along the lines that x has no solution. All right, or you could just say no solution. That's usually pretty acceptable. Okay, so let's solve these, and as you can imagine, we're going to have one of each here. But let me just show you what happens here on these kinds of equations. So on number 27, we're going to execute the distributive property here. And we'll be left with 15x plus 6 equals 15x. And so whether it's an identity or a contradiction, what you'll see is kind of something similar happening with both of these kinds of equations. And that is when you go to combine your linear terms, they'll all cancel out. In other words, like you'll basically lose all of your variables. And so once that happens, you'll be left with either a true statement or a false statement. And then we can decide whether or not it's whether it's an identity or a contradiction. So if I subtract 15x from both sides, you see that they're going to cancel out on the left and the right-hand side. And so when everything cancels out from one side, you're just left with 0. And so we get this statement, 6 equals 0, which is obviously false, okay? That's never going to be true, okay? So that means that what we have here is a contradiction. Okay, 6 cannot equal 0. And so the way we're going to state what our solution set is there's just no solution. So we'll just say there is no solution. No answer can be there's no value that we could plug into x to make that true. With number 28, we will start similarly by using the distributive property here. And so that'll leave me with negative 8y. Let's try that again. Negative 8y equals negative 2 equals, let's try plus. All right, let's slow down here. Negative 8y minus 2, there we go, equals negative 8y minus 2. And just like with the last one, once we try to combine our like terms, we're going to get a statement where we don't have any variables. So we're going to add 8y to both sides. All the variables will drop out because 8y minus 8y is just 0. And we're left with an equation that says negative 2 equals negative 2, which is always true, that any number will always equal itself. Okay, so this is a true statement. And so when you end up with a statement that is always true, we have what we call an identity. And so when that happens, you can say all real numbers. Meaning that x could be any real number. All right, that's the end of our notes for today. Thanks for watching, and y'all have a great day.